put them in for A and B, and we solve for C. It's a little bit different when we are missing a leg. So let's just take a look at that. I'm going to get rid of these numbers. We can keep the same picture, okay? We're already going to know what the answer is because we just did it. But I'm going to show you how the math works. All right, so let's keep this as 3. And now let's label this as a 5. We're going to make this be the one that we don't know. All right, if you know from the last problem, it's a 4, right? But how do we get 4 mathematically? So again, we see our triangle. It's a right triangle. We can see the box in it. We see the information for 2 of the sides, 3 and 5, but we're trying to find the missing side. That's when you use Pythagorean theorem, okay, to find that missing distance. So we recognize first that we have to use Pythagorean theorem, but then we have to put the numbers in the right spots. So here's the right angle. The right angle is always formed by the 2 legs that stands on the legs. So I can see right away I'm missing a leg. Well, if I'm missing a leg, that means I have my hypotenuse, my C. All right. So this 5, I have to recognize that the 5 is my hypotenuse because it has to go in my formula for C. I'm going to erase this. Give me a little bit more. So my C is 5. One of my legs is 3, the other is missing. So these are interchangeable, A and B. They're interchangeable, it doesn't matter. So I'm going to call A what I'm missing, okay? I don't know what this is, so I'm just going to keep it an A. For B, however, I'm going to put in the side for B, which is 3. So take the letters out and only the letters and put the numbers in for those sides. Now it's just a matter of doing the math. I don't know A squared. I'm going to bring that down. Bring down your addition sign. 3 squared, 3 times 3 is 9. Bring down your equal sign. 5 squared, 5 times 5 is 25. Not much different than how we solved the first problem. This is where it's a little different though. And as long as you know how to solve an equation, it doesn't matter. You're going to be fine. But when we solve equations, what we're trying to do is get this variable isolated, get it alone. And so that's our job when we're solving equations. Do whatever it is we need to do, or really undo the problem until the letter's alone. So in this equation, the 9 has been added. It's the first thing we're going to undo by subtracting 9 to eliminate it. This line, you may have noticed at my equal sign, that's your balance point. And so anything that happens on one side of the line must happen on the other side of the line to keep balance. Subtract 9 on that side. 25 minus 9 is 16. Bring down. What's left on the other side is A squared. So I bring it down. Now here we're at the same point we were at the last problem, where I said the last thing you're always going to do is square root, because the side we're looking for squared is 16. So a number times itself is 16. What is that number? What is the square root of 16? A is equal to 4. All right? And so that's Pythagorean theorem. That's how you would solve, basically, that's the 2 kinds of problems you could have with Pythagorean theorem. You need to know, most importantly, when to use it. Okay? If you've been in my class, you're going to know how to use it as long as you plug those in correctly. When to use it, if it's a right triangle and only a right triangle, and you're missing one of the 3 sides. You have 2 sides, you're missing the 3rd. Put them in the right spots. Make sure if they're legs, if they make the right angle, they have to go in to the leg section of the formula, A or B. If it's a C, as in this one, the 5, the hypotenuse must go in to the formula as C. Okay, so that's Pythagorean theorem. I'm going to go ahead and stop the video there, and I'm going to make part 2 where we actually do some practice problems with the worksheets that I sent to you today. All right, so let me know if you have questions, concerns, or comments, but that's Pythagorean theorem.